This next section is going to be some more calculations with gases. And first of all, just a reminder that when you're using something like PivNert, the PV equals nRT, you have to have all of the numbers about the same chemical. So if they give you information about carbon dioxide and information about oxygen, then you'll need to use the balanced reaction that they'll give you or you might have to balance it yourself, to convert one of them into the other one so that all of your numbers that are in the PivNert equation are about the same chemical. So that's part of gas stoichiometry. Another part is just rearranging these equations to get the units that you need. So there's a few things here. We talked about STP the other day. It stands for standard temperature and pressure, and it's just a temperature and pressure that they chose to be standard. So instead of giving you these numbers, they can just say in the question that it's at STP. So standard temperature is 0 degrees Celsius, which is the same as 273 Kelvin, and then standard pressure, it depends on what units you're looking at, but there's a whole list of them. So one thing to keep in mind for this is that if they say that it's at STP in the question, it looks like they're not giving you enough information sometimes because you feel like you're missing some numbers, but you just have to keep in mind that STP is actually giving you two numbers. It's giving you a temperature and a pressure, and you can just look them up. They're in your reference packet if you forget what they are. The next thing is if you ever see the word molar in front of something, it's not talking about your teeth, it means per mole. So molar volume is going to be the liters per mole, so in 1 mole. Molar mass is going to be grams per mole, so that's one thing that will help you with vocabulary if you can remember that molar means per mole. The next two equations are just some derivations, which means like rearranging the variables of the PV equals nRT equation. So this one in particular is a little bit tough to rearrange. I know some of you are probably really good at algebra and calculus, and you're good at doing the math for some of these, but this one in particular is kind of tough to rearrange. So I just memorized this one instead. It's not given to you on the reference packet, but if you just remember the phrase evening dirt, so evening is like PM, like morning is AM, PM would be evening, and then DRT. So it's not a hard one to remember. You do have to know what those units are telling you. So the capital M there stands for molar mass, which is the grams per mole from the periodic table of that particular chemical. So they would have to say in the question something like, what is the density of xenon, or what is the density of krypton, or something. So they would tell you the chemical, and you can get that from the periodic table. So one way that you know that you're going to use this one is they'll either give you a density or they'll ask you for density, and that's your clue that you're going to use this equation. You still have to be careful with your units, so notice that the density unit here is in grams per liter, and that's because the R value usually has liters as part of its unit. So again, just make sure everything matches. If they happen to give you density in grams per milliliter, which is a common way to express density, then you have to get it to grams per liter before you plug it in. So again, anytime you plug numbers into an equation, you need to check all your units, make sure the units are supposed to cancel, make sure they do if they're supposed to cancel, and if they're not supposed to cancel, it should be the unit that you want to end up with. The next equation, so this is a list of a lot of them. The next one I want to highlight is this one. So we've talked about the rest of these. The first three are just the two variable relationships, and remember that's only those happen if the third variable is held constant. Combined gas law is all 6 of them if nothing is held constant. We did the ideal gas law yesterday, and we just did the PM equals DRT1. So this last one is this one that has the M's in it. And this one is kind of hard for me to remember because there's 2 different M's, and I can't remember, which M goes on which side or whatever. So I actually don't use this one. What I use is PivNert. What this is relating is the moles and the grams. So if they give you grams of something and ask you for the moles, or they give you the moles and all the information and ask you for the grams or something. So what I usually do is I focus on PivNert and focus on the moles. And then I can easily remember that on the periodic table that the molar mass of something is the grams per mole. So you actually plug the moles in down here. And then either you'll know the molar mass, or if they gave you the grams, you can plug it in and get the molar mass, but they'll give you one of these two in the question, and you can usually solve for moles using PivNert and then plug it in. So I prefer to do 2 equations because the double M in that confuses me, and I can't ever remember which one is which. But if you like to use the other one that I circled in blue, just keep in mind that the lowercase m stands for mass, which is in grams, and then the capital M is molar mass from the periodic table. That's the grams per mole. All right, and the last one for today is Dalton's law of partial pressures. This one seems like it's so easy that it's not even a law, but not everything is additive, so not all variables you can add together to get a total, but you can for pressures if you have a mixture of gases. So what this is saying is if you have two different gases in one container, the total pressure is equal to the individual pressures of each gas, and we call those partial pressures. So for example, if we have a balloon that has both O2 and CO2, the number of times that oxygen hits the walls of the container would be the partial pressure of oxygen. The number of times that carbon dioxide hits the balloon would be the partial pressure of CO2. And then the total pressure would be the total number of times that they both hit the walls of the balloon. So the equation is just however many gases you have, you can add up the partial pressures to get the total. Two more things. One is this next thing called mole fraction. You're going to see this periodically throughout AP Chemistry. Mole fraction is kind of like a percent without the 100. So the mole fraction of something is a mole part over the mole total, and that's it. So notice N1 over the N total, and just don't multiply by 100. And there's this relationship that can help you solve things sometimes. Because the number of moles are related to the pressure, you can also set those equal to each other as well. So the mole part over the mole total is equal to the partial pressure of that chemical, whatever you had the moles of, over the total pressure. So sometimes you can use this relationship to solve for one of those variables. And then the last thing, I think we talked about this in our review, but you can collect a gas on top of water because a gas will push the water out of the way, so it allows you to collect the gas. Otherwise, it's kind of difficult to collect gas because it just kind of floats up into the air. So this is one way you can do it. But the problem is that water always is evaporating, and so you not only have the gas that you're collecting, oops, sorry about that. You not only have the gas that you're collecting right here, but you also have some water that has evaporated, and so you have little gas water particles bouncing around as well. So you have a mixture of the two gases here, and then those are going to equal the total, and a lot of times they'll call that the atmospheric pressure, because if the balloon is not getting bigger or smaller, then the total pressure inside the container is going to be equal to the atmospheric pressure. So a couple of things about this. Sometimes, like I said, they give you atmospheric pressure instead of calling it the total, so be aware of that. The other is that this water vapor is dependent on the temperature of the water. So the hotter that you make water, the more it evaporates, which means you'd have a higher pressure. So in the question, they're going to give you all kinds of information about the temperature of the water and how this is the water vapor pressure of water at that temperature. And a lot of people think that temperature is in the equation somewhere, so they might try to use PivNerd or something, and it kind of confuses them. So just be aware that if you see this phrase in the question, that you're collecting gas over water, that it's just a simple addition of the gas plus the water vapor is going to be the total, or the atmospheric pressure. And just don't worry about all the temperatures that they're giving you in that. They have to give you those temperatures because, like I said, the water vapor pressure is dependent on that temperature, but you just don't use it in the equation. And that's it for today.